Okay, I'm recording, but there's like a worldwide issue with Google Meet recording today. So can somebody take really good notes just in case the recording doesn't work?
I can do.
Okay, thanks. So I can give them a call.
You're welcome.
All right, so yesterday we talked about modeling with differential equations. Any problems on that? Questions? Anything like that? Okay, so today this is the kind of the last topic dealing with Unit 7. We'll talk about it some more tomorrow, but it's the same topic. And it's slope fields. Okay, sometimes in some textbooks these are called different things. Sometimes they're called directional fields or direction fields. Or sometimes they're called vector fields. It's the same thing. It's all the same thing. Okay. So a slope field is it's like a visual representation of a differential equation. Okay. Slope field is visual representation of differential equation. I'm not sure how to put this in words, but it's given by a kind of like a rectangular array of points. Okay. Rectangular array of points. And little line segments at each point with this appropriate slope at that point, okay? And line segments at each point with the appropriate slope. That sounds weird and confusing, but it's actually really, really easy. In my opinion, it's like the easiest thing in AP Calculus. Okay? So here's what I mean by this weird mumbo jumbo. Like, for example, suppose I have a really easy differential equation like dy dx equals x squared. Okay? If I had to provide a slope field for this differential equation, the way that the question would be worded is they give you an x and y axis, and they'd specify what points they wanted you to provide the slope field for. Okay, so in this case, suppose I just wanted to provide the slope field for 25 points. Okay, so the 25 points are all the points from -2 to +2 in the x direction, and from -2 to +2 in the y direction at the integers. So like the points that are just at the intersection of integers like this. Okay, so if I just put the points in, there's 25 points that I'm putting in right now. Okay, this is what the problem would look like on the AP exam or whatever. They would give you this rectangular array of points. This, okay? And all you would do is, at each point, just draw a short little line segment that has the appropriate slope. Like, for example, if I look at whenever x is 0, this dy dx is going to be 0 as well, right? Whenever x is 0, x squared is 0. So all I'm going to do is I'm just going to draw a little short line segment of slope 0 at every point where x is 0. So I'm not really doing like 25 individual things. I'm seeing patterns, right? Whenever x is 0, the slope should be 0. That covered 1/5 of the points, right? Whenever x is 1, the slope should be 1. So I'm going to draw a little segment of slope 1. Now, nobody's going to take out like a protractor and make sure that's exactly 45 degrees, okay? When they're grading your test. They're looking for like relative steepness, okay? So like the next slopes should be 4. They should be steeper than these ones, right? They're not going to actually measure to make sure that it's 4, but they just want to see a positive slope line that's steeper than the other one that you drew. If I go the other direction, if x is -1, x squared is also 1, right? So this should be a slope of 1. And again, what they're looking for is, generally, does it appear as if you recognize the fact that the slopes here are the same as the slopes here? That's what they're looking for. Do they look the same? And then at -2, again, it should be 4. So this is just going to be a steeper line segment, but that's still positive. So that's what this slope field looks like. Super easy, don't you think? You're just taking points, substituting them in to the differential equation, figuring out what the slope is, and then drawing an appropriately sloped little line segment. Okay? There's slope field generators that you can find online, like here's one on the Desmos graphing calculator, and it just looks like this. I mean, this is x squared. This is the slope field for x squared. They did it a lot more points than I did. And if I kind of zoom out, I mean, you can see it. It looks pretty stupid. Like once you get far away from 0, because like at this point the slope is 36. At this point the slope is 49. Well, a little tiny line segment with slope 36 looks a lot like a little tiny line segment with slope 49. So they don't really look that different, right? But essentially what you're doing is you can actually figure out what any solution to this differential equation might look like, approximately, just by following these like contours. Think of it like a contour map, like in earth science or whatever, right? Like, for example, if I wanted to figure out what the solution looks like that passes through this point right here, right? Just follow the lines. It kind of goes down like this, right? Getting steeper and steeper and steeper. As we move to the right, it's going to get flat, and then it's going to go up. Well, I know that that's what the solutions to this differential equation x squared look like, right? Because its solution, if you think about the solution to this differential equation, integrate, you get y equals x cubed over 3 plus c. So it's going to be like a cubic looking equation. Good thing that's what I got, right? It's just sort of a visual representation that gives you like the entire family of curves without having to draw like all the family of curves. It's just giving you sort of like indication of where to go. Does that make sense? Tomorrow we're going to talk more about like how it's used to find specific solutions or approximate specific solutions and other questions they might ask about the slope field. But for today, all you have to do is just produce a slope field. It's super easy, okay? Let me give you a couple other examples. Suppose we had something like dy dx. The previous example I gave only had x's, right? Often the differential equation will contain x's and y's, okay? So like, let's suppose this is something like negative y over x, or something like that. Again, try and come up with generalizations so that you don't have to do so much work, right? Again, I'm not going to draw all the dots. I'm just going to draw the tick marks on my axes. Okay, but let's just assume each of these points represents like an integer. So it's like 1, 2, and -1, -2. So, I mean, the things I'm going to look for when I'm producing a slope field are, first of all, when is the thing 0? Because those points are going to be really easy to draw the slope field for, right? So this thing is 0 whenever y is 0, with the exception of when x is 0. At the origin, it's not 0 anymore, right? It's 0 over 0, which is undefined. So I'm going to draw every point where y is 0, except at the origin, as a 0 slope segment. 0 slope segment all along the x-axis where y is 0. The second thing I'm going to look for is when is this undefined? This is undefined whenever x is 0, right? So the way I'm going to represent that on my slope field is just a little vertical line. Now that doesn't mean that the graph necessarily is vertical, but that's the way you represent it on the slope field, is a little tiny vertical line. It's possible there might be an asymptote at that point, right? It's possible there might be a vertical tangent, or it's possible there might be something else occurring, right? There might be a corner or some other situation in which the derivative is undefined, right? But all I'm going to do is I'm just going to represent it by little vertical line segments on the y-axis. So I've made it so instead of now having 25 points that I have to actually plug in and like do this time-consuming work, I've made it so that I really only have 12 points, right? 4 here, 4 there, 4 here, 4 there. But maybe it's possible I can come up with other generalizations. Like, for example, whenever x and y are equal, this is going to either, or whenever x and y are equal, this is going to equal -1, right? For sure, even if they're both negative. If they're both negative and they're equal, it's -1. If they're both positive and they're equal, it's -1. So everywhere along y equals x, where x and y are equal, it's going to be a slope of -1. So it's going to be -1 here, -1 here, -1 here, and -1 here. Whenever x and y are negatives of each other, in other words, along the line y equals -x, what is that slope going to be? +1, right? If x and y are negatives of each other, then y over x would be -1, and negative y over x would be +1. So all along this diagonal, I'm just going to draw little line segments of slope +1. So just by observing patterns, now I only have 8 points to evaluate this thing at. Does that make sense? So you want to look for ways, instead of just starting at -2, 2, plugging that in, figuring out what it is, and then -2 or -1, 2, plugging that in. That would be really a lot of wasted time. Try and observe patterns like this, okay? So if I substitute in, for example, -1, 2, or 1, -2, it's going to give me the same answer. Whatever the slope is here should be the same as whatever the slope is here. Same with these points, same with these points, same with these points, right? So if I substitute in -1, 2, right, this is going to end up being -2 over -1, which is +2. So I have a positive slope line here, 2, and a positive slope line here, 2. Is that logical? If I substitute in 1, 2, then it's just going to be a slope of -2. Same thing down here, -2. If I substitute in 2, 1, it's a slope of -1/2. So again, I want to draw a line that's less slopey than that, right? But still negative, something like that. And it's going to be the same over here, like that. And then the last two remaining points, they're going to have a slope of 1/2. So again, I don't want it to be as steep as a slope of 1. So you have to be kind of careful here. I mean, you don't have to measure anything out, but you want to get it to look like it should look. Okay? Any questions so far?
How is delta math going to model these problems?
That's a great question. There's a couple different things that they might do. One thing they might do, and I'll actually show you delta math in a second, but first I just want to do one other thing. One thing they might do is they might give you like a matching situation. Okay, so I have a matching problem here. Yeah. So it would look like this. They give you 8 different slope fields and 8 different differential equations, and you have to match them up. Okay. So again, I'm going to do the same strategy here. Like, for example, if I look at this first slope field, I see that everywhere along the y-axis, it's 0, right? So that means whenever x is 0, this differential equation should be 0. So that rules out a lot of them, right? I mean, the only one here that has x value where it's equal to 0 when x is 0 is that one. So that has to be 10. That makes sense? Same thing like along here. Like I know that along the line, y equals x minus 1. I don't know if that's helpful. Hang on a second. Let's stick with zeros and undefined. Here, this one's 0 whenever x is equal to 2, it looks like, right? So which one of these is 0 when x equals 2? This one. 11 is, right? So this one must be 11, and so on. So this is one type of question, like a matching question. This is something you're likely to see on the AP exam as well, a matching type question. Or maybe they'll just give you, well, I've seen different things. Okay, I've seen questions where they give you a differential equation and they say which of the slope fields could be the slope field for this differential equation. And then I've seen ones where they give you a slope field and they say which of these differential equations could yield this slope field. Same strategy either way, right? So the second type of problem is actually drawing a slope field, which I thought the math is not super ideal, but they have it. So let me just show you what that looks like.
Wait, so Mr. Baxter,
Yeah.
when you're like looking at a graph though, and you're just like trying to find where like x is 0, you don't like actually do anything with the equation. You just like look at it, right? Like you don't integrate or anything.
Correct, yeah.
You
I'm
just
not
like
finding
look at it for what it is.
exactly. Like looking at this one right here. This one's going to be 0 whenever y is 0. So I'm going to look for a slope field where it's little 0 line segments all along the x-axis.
So it'd be G.
Looks like this one, yeah.
Okay.
You know what I mean?
I'm just making sure.
Yeah. Okay. So here's the typical assignment where you have to create a slope field. So they're giving you a differential equation, and they give you just random lines of slope 1. This is not what the slope field looks like. They want you to change the slopes so that it looks like what it's supposed to look like. So again, I would do the same strategy. I would say this is going to be 0 whenever x is -1 or y is -1. So if x is -1, that corresponds to these 3 points. So I'm just going to change them all to be 0 along that. Let me use the mouse. Along this vertical line, I'm going to change them all to be 0. In addition, along this horizontal line, I'm going to change them all to be 0. So now I've narrowed it down so I only have 4 points to do it at, right? If I plug in 0, 0, it's definitely 1, so I can leave that one alone. If I substitute in 0, 1, that's going to give me 1 here and 4 here, right? So I just got to make it a little bit steeper.
Do the lines have jets on the map or no?
Jets?
It's like where they like click into place a little bit.
Oh, I see what you're saying. No. Other than 0, I haven't noticed that. Or 0 or vertical. So yeah, so if a slope of 4, if you left it like that, it's okay. If you left it like that, it's okay. You know what I mean? If I plug in the point 1, 0, it's the same thing. It's going to give me 4. So I'm just going to make it look kind of steep like that. And then finally, if I plug in 1, 1, I get 4 times 4 is 16. So I got to make that look a little bit steeper, almost vertical, but not quite. And then I just submit, and boom, and that's it. Like, it's pretty close. If you look at the red lines that they drew, that's what it's supposed to look like. But I was close enough.
Yeah.
You know what I mean? And that's all they're looking for, is it close enough? And same thing when you do this on the AP exam. Nobody's going to measure anything. They're just looking for, is it pretty close? Like, do you have an idea of what you're doing? That's what they're looking for. Okay, and then the second part of this assignment, like I said, is like a matching multiple choice type thing. Like here they give you a slope field, and they want you to figure out which differential equation goes with it. So again, it's whenever y is 4. So which one of these is 0 when y is 4? all but the last one. All right, so that's not too helpful. It doesn't really narrow it down. These are all 0 when y equals 4. So then I'm going to look at undefined points. This is undefined at x equals 0. Well, the only one that's 0 when y is 4 and undefined when x is 0 is this one. It has to be that one. I didn't have to do any other work in terms of like figuring out any other points or anything like that. If I just submit this, that's the answer. You got it?
Yeah.
Okay. Let's do a problem of the day. I actually have 2 problems of the day. One that's just a random problem, and then one that involves slope fields.
So it really just does nothing with like integration or what we're learning. It's just kind of like,
It has to do with differential equations.
yeah.
So that's why it's in this chapter.
But like
But in terms of actually doing like a process,
calculus or something.
yeah, we're not really doing calculus other than just connecting that this is actually a visual representation of a differential equation.
Yeah, okay.
All right, so what happened? Let's see. All right, I'll find it. Just give me 1 second.
Trace of this, like, if someone were to look at this, they'd probably be like, oh, that looks so complicated and so hard. But it's like actually not at all.
Yeah, it's actually the easiest thing,
Yeah.
I think, that we do.
We're gonna do a warm-up as well. Why do we? Yeah, we can do a warm-up, 10:42.
All right, so the first question, let's do actually the slope field one first. And this is in the calculator section of the test, which calculators aren't really helpful for this. You can actually have a program on your calculator that that does differential equation or that does slope fields for you, but I think it's harder to use that program than it is to just do slope field by hand. So I wouldn't recommend it. All right, so here's a typical multiple choice question. They're saying this is a slope field for a differential equation, and they're saying if f of x or if y equals f of x is the particular solution that passes through the point 1, -1, 2. So going through this point right here, I mean, you could sort of graph what that solution might look like. It looks like it's going to sort of like be like that, right? If you wanted to graph the particular solution that passes through that point, okay? But that's not what they ask you to do. They say if you have this other function, h of x, then what's h prime of -1? So what do you do here? Let's just talk it through. Who has an idea? This is an actual question off the 2016 exam.
Find h prime of x. Yeah.
How do you do that?
Yeah.
So, but how do you, specifically, what are we going to be using? Product rule, right? So this is going to be the first times the derivative of the second. Plus the second times the derivative of the first. Okay, and then just substitute in x equals -1. So h prime of -1 is going to be 3 times -1 times, what is f prime of -1? Yeah, it's the slope of the line that they gave us in the slope field, which is -2. You can just look at the squares, it's -2, right? Plus f of 1, what's f of -1? It's 2. They gave it to you right here. So that's all there is to it. This is just 6 plus 6. The answer is 12. Does that make sense? But again, you had to make the connection about what a slope field is. These represent the slopes at particular points. Okay, so that's the first question I wanted to show you. The second question is not related to slope fields, but it's a topic we haven't talked about in a little while. So it's number 20. Roll up. So this number 20 is a non-calculator question. So what are your thoughts? When you see something like this, what should be your first thought? FTC part 2, h prime is equal to sine squared of x. That's my first thing I'm going to do when I look at this problem without reading any of the words. When I see a definite integral where x is one of the limits of integration, this is the first thing I'm going to do. Okay, so the question says, what's the equation of the tangent line to h where x is pi over 4? So now it's easy. Once you've made this connection, the question is pretty easy. You need a point and a slope to find the equation of a line, right? The point is going to be pi over 4, h of pi over 4. But what's h of pi over 4? 0, because you're going from pi over 4 to pi over 4. So this is really pi over 4, 0. Cool. And the slope is going to be h prime of pi over 4, which is really sine squared of pi over 4. What's the sine of pi over 4? Nope. Radical 2 over 2. It's 45 degrees, right? So this is radical 2 over 2 squared, which is 1/2. So it has to be this one. That's it. Does everybody understand that? Even if you just made this connection and said the slope is 1/2, that narrows it down like significantly, right? This is actually the only line that has a slope of 1/2. Slope of this line is 1. This one's radical 2. This is a horizontal line, so slope is 0. And this one's radical 2 over 2. So it has to be that one, even if you didn't get the point part. Everybody understand? All right. So that's it. The homework tonight is on Delta Math, and it's just called, I think it's called sketching slope fields. Tomorrow we'll talk more about free response questions that involve slope fields.